Hello, and thanks for joining us for this Tech Talk presented by PHEMI Systems Corporation. At the heart of any data-driven organization is the core tenet around sharing data responsibly. In earlier videos, we've explored the topic of access controls, making sure that authorized people can see what they're allowed to see. Now, let's look at the other side of the coin. How do I restrict access to sensitive data, but still maximize the value and appropriate use of information? Let's talk about de-identification. For instance, let's consider a typical file or table. General guidelines require that anything that can be traced back to an individual would be considered private and should be removed as part of a de-identification process. HIPAA, a healthcare privacy protection regulation, specifies 18 direct identifiers that need to be removed for de-identification and data privacy purposes. Things like name, date of birth, customer number, patient number, phone number, credit card number, email address, and so on. And with this information removed, we now have a data set that can be freely shared across the organization. Terrific. Of course, de-identification leads to heavy information loss, which may limit the usefulness of the resulting data set. For instance, maybe I'd like to do an analysis of people over the age of 50, or those living in the city of Los Angeles. Masking information is a fine first step for some, but usually we need to go further. We need to protect privacy, but at the same time we want to maximize the value and appropriate use of information. A more sophisticated approach would be to modify the sensitive fields somehow to make sure that it isn't identifiable, but without compromising its usefulness for analytics. And so one can take the original data and apply certain transform functions. Let's consider the data field for a moment. We can mask the data so that the date is either hidden or it's a series of asterisks, or it's forced to a common value like 999. We can truncate things like dates to the year, 1932 for example. We can introduce some error into the data such that the date may be March 28th plus or minus up to 5 days to preserve the format and structure of the data. We can group dates into ranges such as Q1 1930 or 1930 to 1940. We can even overwrite the data to the first of the month, such as March 1st, 1932, and keep the format and structure intact. In all these cases, it's very, very difficult to attribute the data to any one individual, yet we're still able to get some valuable insights from the data. This is a far superior approach to protecting privacy without significantly restricting the analytic value of the underlying data. A strong element of any privacy and data protection solution should include a comprehensive set of de-identification libraries so that you can maintain the analytic value of your data while still protecting privacy. Of course, de-identification is a careful balancing act. Let's take the hypothetical data set here where I have a list of patients with diabetes. We've de-identified the data set to remove names and addresses. We've truncated the date field to the year of birth. And in that data set that you see here, I only have one patient over the age of 50 who was born in Korea. Clearly, that individual is at a high risk of re-identification. In many situations, that risk would be unacceptable, and so an important element of any privacy and data protection solution should calculate and report the risk of re-identification for compliance purposes, and either adjust the de-identification algorithms or filter the dataset to meet an acceptable risk threshold. The PHEMI system, for example, de-identifies the data, and then we calculate the risk of re-identification based on 3 different attributes. The dataset sensitivity. For instance, a dataset containing weather patterns is considerably lower risk than a dataset containing income levels. A user trust, for instance. A user who is a vice president or a business analyst may be lower risk than a partner or a summer intern. And the location controls are also an important factor. A dataset that's analyzed on a secure server may be lower risk than a dataset that is downloaded to a user's desktop. This is a particularly powerful approach because a user can safely download a dataset to their desktop, look at it, Then if they're interested, go through a governance approval to see more detailed data sets in a more secure location. So in this video, we considered de-identification as a means to retain the analytic value of data without compromising privacy. There are three key elements to an effective de-identification strategy. Employing a variety of de-identification functions to make sure that no individual can be re-identified. Understanding the restrictions that require groupings like HIPAA, safe harbor guidelines to those over the age of 89, those of a certain geographic population, and so on. And thirdly, to quantify the business value and risk of re-identification and adjust the dataset accordingly with minimal friction to your data workflow. By coupling de-identification techniques with PHEMI selective access controls, rules can be uniformly and consistently enforced for all users and applications, at speed and at scale. People can only see what they're allowed to see. In this case, Rachel can see fully identified information, Alice can see dates that are forced to January 1, postal codes that have been forced to the nearest 3 digits, and names that have been masked. Meanwhile, Michael can only see 2 fields, postal codes that have been forced to the first 3 digits. With PHEMI Central, you can lower your data management cost, complexity, and risk of a data breach. One SQL query, one table, one visualization dashboard, one access policy. That's privacy and data protection built for scale. To learn more about PHEMI and how you can share data responsibly, please contact info@phemi.com or visit us at www.phemi.com. Thank you.